Hello guys, welcome back to our channel again. Today we will solve the fifth question of July Leetcode challenge. So our question is Hamming distance. So our video will be divided into three parts. First the question discussion, then the solution discussion. After that our implementation part or the code discussion part will come. First of all, we will understand the question. So in the question we have given two integers x and y, where we have to find their bit difference. So what we have to do, first of all we have to convert these both into their bits or their binary representation, and then we have to compare each index, and then we have to find that how many different numbers are there or how many different bits are there. Suppose here it is 0, here it is 1, here it is 1, here it is 0. So we will count it equals to 2. So in this case our answer will be 2. So in combine, what we have to do, we have to find the different bits in two integers. Now for understanding the solution and approach, we will take x equals to 1 and y equals to 31. So in the first step, what we have to do, we have to convert them into their binary representation. So what the binary representation of 1? It is 1. And what is the binary representation of 31? It is 1 1 1 1 1, 5 times 1. So if we have to make x or comparable to this, we will convert, or we will add, starting at the beginning we will add zeros. So this will be our binary representation of this 1 and 31. Now after that we will compare everyone. So in this case, this is 1, this is 1, this is 1, this is 1, and all the above there are zeros, and at the last there are 1. So answer will be 4 in this case. So this we have manually find out. So if we find out their x or, then we can directly calculate our answer. Suppose if there are two numbers, 1 0 0 0 1 and 0 1 1 1 1 1 0. So these are the two numbers. Now if we find the XOR of them, suppose this is the XOR, so 1. So what will be the XOR? XOR will be 1 1 1 1 1 1. So these 6 ones will be there, and then in the number we will count their numbers. So in this case it will be 1 2 3 4 5 6 7 is the answer in this case. Now we have to approach. First of all, we will find the XOR and then we will count the number of ones. Or we have one more approach, that we will convert, or we will check that after every binary representation, that 1, suppose 1, then we'll check for 2, then we'll check for 4, then we'll check for 8, then we'll check for 16, and till doing this we'll compare to 2 to the power 31. And after every comparison we will find the end of both. So we will find 1 and with 1. So we will find this, so 1 and 1. So it will be, if this comes to be equals to 1, so this comes equals to, sorry, if this do not comes equals to 0, then the number or the bit here is 1. Similarly we will do this thing for other number also. So we'll do 31 and 1. So if this is also not 0, so what we have to do, check that these both should be different. If these both are not different, then we will submit, or then we will count, or then we will increment. Because if they both are not similar, if this is somewhat 1, suppose this is 1 and this is 0, so by this we can easily understand that their binary representation at one index, they both are not equal. So we have discussed two approaches. First approach is this, the XOR approach. First of all we will find the XOR and then we will count the number of ones, and second is to check every 2 to the power values or every bit one by one, and then we will check that if they are both and are coming same or not. If coming same, then we will go for the next one, else we will increment the count and then we will proceed for next one. So now we will implement both and then we will check that which one is best. So this is the first implementation. In first of all, we have find the exclusive OR and we have stored that into the T. Then afterwards I have initialized the count with initially 0. Now what I am doing, I am here counting the number of ones. Suppose if number is 1 0 1 1 1 0, and first of all it will count this one, sorry, it will count this last one, and then will subtract it, then the value will become 1 0 1 0, sorry, 1 0 1, and we will find the AND. So this one will be removed. After this one will be removed definitely. So now the new value will become this. Again we will do the same thing. We will subtract 1, so it will be 1 0 1 0 1 0. Again we will find the AND, so it will again, sorry, here it will be 1, so again we will find the AND, so again the value will be changed. So the value what it will be, it will be 0 here. So after every iteration 1 0 or 1 is removed and 1 0 is added. So by using this loop or by using this, we can easily find the number of ones. So this is the first implementation in which I am finding the number of ones with the help of exclusive XOR operator. So this is the second approach solution, in which first of all here I have initialized the counter. After that I have iterated all the bits, the maximum bit size which is 32. After that, first of all I have finded the bits number which will be 2 to the power I. So if suppose I is equals to 1, so it will be 2 to the power 1. If it is 2, then 2 to the power 2. So all the binary representation, it will be occur. First it will be 0, sorry, first it will be 1, then 2, then 4, then 8, then 16. So like this all the numbers will iterate. After that there is two values, we are just finding the AND with these both X and Y, here with X and here with Y. Now I am checking that these both are different, then I am incrementing the count, and at the end I have written the count. So our count will be stored in CO, and at the end I will return this count. So now if I submit the solution, I got correct answer, and in previous also I got correct answer. And if I see more details, both have the fastest time complexity. The previous one also has the 100% time complexity, and in this also it is 100% time complexity. But memory usage is greater. In this it is 39.20% of C++ emissions, whereas the previous one was up to 90%. So I prefer the previous one, because in that we have to just find the XOR and then we have to count the number of bits, whereas in this we have to find the every bits, or we have to find for every bit, and then we have to compare that both are different or not. If both are different, then we are considering that to be answered. If that both are not different, then that will be not answered. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.